Good morning everyone, hope you're doing alright, having an awesome day and stuff like that. It's been a while since I've uploaded a video, so here it goes, a little update on the heartbeat monitor slash cardiograph I've been working on. I'm sorry about the poor video quality. I'm using my phone with an app called Droidcam that is streaming video over Wi-Fi, so things might get a little bit laggy. It's pretty cool, but far from optimal, so please bear with me here. As for the circuit, it's pretty much unchanged with the exception of I added a cool finger attachment, finger sensor, which replaces the old LEDs I had in the front here. So what I've done there is, for those who haven't seen the old diagram, here it is. This is what I'm using as a circuit to actually measure my heartbeat and send it to the Arduino. I've replaced this photodiode and this infrared LED with this finger attachment, and that finger attachment connects on this point, and on the ground with the help of a 3.5mm jack. So I still have to make a jack socket for that, but program wise I'm using Telemetry Viewer, which is made by a YouTuber called Upgrade Man. Check out his channel. He has lots of cool content regarding Arduino and coding and all sorts of nerdy electronic goodness, and well, check his channel out. Big shout out to him. He has easy telemetry, fast telemetry, advanced telemetry, etc, etc. Big shout out to Upgrade Man. Be sure to check out his channel as well. As for the Arduino code, let's put myself back in there. As for the Arduino code, I've replaced the entire code I had with the code I found at Adafruit. If you Google Adafruit pulse sensor, you'll get this code, which I've modified and edited a bit. I've added the signal readout, the interval between beats, and a time pass data string or serial or symbol data, whatever you want to call it, parameter. So that being said, one major improvement is that everything is being generated on the Arduino itself in terms of BPM data and stuff like that, so no more coding and processing. That data is being sent to Telemetry Viewer over serial, and Telemetry Viewer just reads that, and then we'll get into Telemetry Viewer, which uses sample rates as a sort of timekeeping method or timestamp. So I'm currently sampling at 500 Hertz, which means every second there'll be 500 Hertz sampled. So am I saying that correctly? Yeah, probably. I didn't write the program, so I don't know exactly how it all works, but anyways, as for these data containers, these all work on samples. It's basically a container that stores X amount of samples and displays it over, well, time, or over this sample rate period. So what we have here at the top is, let's just shrink myself down a bit here. What we have at the top is the real-time input of the heartbeat, and there you can see all these different sample sizes for the containers. As this container is being sampled at 100 samples, this container is being sampled at 1000 samples, and this container is being sampled at 2500 samples. So that's why one container looks zoomed in more than the other. And that's another feature of this program. You can actually zoom into your data set, scroll back in time, and freeze that data for that particular time. And the cool thing about it is it will actually store all those samples. All those containers will move back in time. So, for example, here we have a BPM readout that's being sampled at with a container size of 10,000 samples, and here we have a BPM histogram readout that's being sampled at with a container of 10,000 samples. So these two pretty much are the same. So if we scroll, we can actually see an average of this in this container in histogram form. So that's pretty neat, and if we zoom out, that changes as well. You can see the container sample size actually changes, and I'm calling this a container. I'm not sure what the author of this originally calls these little boxes, but you can basically configure each box to display a certain value, which is being read from the serial port. So, for example, if we say, no, let's not change that. I've just got it the way I want it. So let's talk a bit about all these different, let's just have a look, see, at all these different containers here, what they all display. So the top row is all real-time heartbeat, the second row is all BPM, and the right one is a zoomed-in version, the middle one is a, well, just a overview version, the left one is a slightly longer history version, and the left one is more as a log keeping, as an overall, well, overview. Then we have these histogram boxes displaying the BPM for the entire session, the BPM for the last 10,000 samples, and the BPM average for the last 1,000 samples. So these two will change according to what's happening here. Then there's the interval between beats. Same story as with the BPM here. One shorter period and one longer period, and two histograms. And the same story goes for this. One average over the last 1,000 samples and one for the entire session. And then we get to, well, a proper heartbeat measurement. What you really want is, well, a nice clustered pair of interval between beats, which indicates a healthy heartbeat. So it's looking pretty normal. There's no abnormalities like one data point at 3,000 or something like that. For example, when you have a skipped heartbeat. Then we have a real-time BPM readout. Then we have an interval between beats. Then we have the seconds, which correlates to the sample number. So, well, yeah, this program keeps time in samples. And because it does that, I added a seconds value to the Arduino, so you can actually correlate and actually zoom back in time and look up certain events, like, for example, what happened there at that little dip there? When was that? And then you can see it's at sample 51,600, and that correlates to 1,024 seconds. So you can actually keep a log that way. Furthermore, well, it's a pretty good device. Of course, it's not medically rated. It doesn't have, well, nearly the high-tech engineering a medical device does. It lacks proper shielding, a good power supply, grounding, and stuff like that. But it's great for just doing basic biofeedback training and using it while meditating or listening to music, and just see how certain things affect your heartbeat and overall mood and stuff like that. It's also great to spot if you have any, if you have arrhythmia, which it does actually pick up. I've seen it on my own heartbeat a few times. So, well, that's about it for Telemetry Viewer. What I want to do next is basically I've switched from an Uno to a Nano V3, and I'm going to redo the entire circuit for the heartbeat monitoring. So it all basically fits in one breadboard, and I'm gonna make a shared power supply. So both the heartbeat monitor circuit and the Arduino itself is powered off the same power supply, which isn't the case at the moment. They're both plugged in my computer though, so it doesn't have a shared power supply at the moment. So yeah, well, let's just have a short meditation session. Let's just see how low we can go. Not too low, I think, because I'm recording a video, which is kind of stressful in itself, but yeah, that's about it. I think I covered everything that I wanted to say. If you want to have the Arduino project files, I'll host those in the video description, so be sure to check that out. And well, the Arduino project are 3 files, so be sure to have them all in the same folder while you're uploading your sketch. And that's about it for the Telemetry Viewer and Heartbeat Monitor update. Be sure to check out Upgrade Man, he has a cool channel. As for my channel, thanks to all my subscribers who still are subscribed. Hope you like this video. I thought I'd make some new content for you guys, so what I have planned for the future is an upcoming live stream where I will build this flight panel for my brother, which he basically built, and I'm going to wire it up using 3 Arduino Megas, and well, basically just do a bunch of soldering and yeah, making it ready for his flight sim. So that'll be a fun little live stream, I think. I don't know exactly when I'm going to do it. I still have to order a few parts, like a few resistors I'm missing at the moment, but stay tuned for that. As for my main channel, those who haven't seen it yet, be sure to check it out. I have lots of Maya tutorials over there, some of my own music, some cool playlists you definitely might want to check out if you like good music and stuff like that. And well, yeah, that's about it for now, I think. Hope you have a great day, and thanks for watching. Hope you enjoyed this video. Take care. Bye.